The linked production of passenger car crankshafts also starts with billets, induction heated to forging temperature. The corners are flattened and the surface is descaled. The pre- and finish forging of a 5-cylinder crankshaft is performed in plain dies. Afterwards, the workpiece is clipped, the flash goes to the scrap bin, while the crankshaft is transported to the next station. A twister, an operation in which 5 strokes of the shaft are properly aligned relative to one another by twisting. The final operation in the production of crankshafts is hot sizing. During this process, the crankshaft receives its required accuracy in form and dimension. The dimensions are automatically tested and documented in accordance with a sampling plan by a 3-coordinate measuring machine.
Blank in there, you do a pre-charge, which is putting pressure on the blank to hold it to the tool to start forming, and then you set your pressures to draw. You have a top pressure that controls a lot of your material thin out and everything. So you start the draw process, and then whenever you get to your top pressure, there's a displacement inside the chamber that allows that oil to dissipate so you don't build up any more pressure. And you draw up and you set a high limit for your draw. It'll kick the punch out when you achieve your total depth, and then you raise the dome and you strip your punch out, and then you take the part out of the press, and that's your process. It was a very unique shape. There's intricate angles to it, and working with brass is a tough part to work with, because when you draw it up, it work hardens. So then you have to do some work to it in order to be able to do some of the shapes we do, the forming we do to it. Hydroforming, you can draw the part up with pressure.
digital modeling to a master plaster design. This master was then used to create the special cast mold that shaped the coin. With the mold prepared, they were ready to cast the molten gold. Assay technologists certified the 5/9 gold purity before and after each cast. Creating the perfect mold for this exceptional bullion coin required Royal Canadian Mint engineering expertise. It was designed so that the molten gold flowed evenly throughout the pour to avoid imperfections. It had to be strong enough to accommodate 100 kilos of gold at over 1200 degrees Celsius, yet fragile enough to release the bullion coin when it was cool. The mold sat in a bin surrounded by a special kind of heated sand to provide the best possible casting conditions. When the gold cooled, the Royal Canadian Mint specialists removed all the mold material, leaving the bullion coin, in need of some cleaning, with the gating system through which the gold was poured still attached. After a surface cleaning, the bullion coin went to the machine shop to remove the excess weight and to machine the circumference to a perfectly shaped circle. The bullion coin was given a thorough quality inspection, weighed, measured, and checked. Even the contours of the maple leaf design were expertly inspected. Once the bullion coin passed this stringent testing, both coin surfaces were primed by hand prior to the polishing stage. To achieve the most desirable finish, the coin went through several stages of hand polishing. Finally, the frosted finish was applied. The result is spectacular.
The reality today is that the Royal Canadian Mint